Hello, Professor Sargent here with you again, and we're going to take a look at analyzing and graphing rational functions. We are lucky in this first one that the numerator is only linear, and furthermore that the denominator is already factored. We can't divide by 0, so the product x times the quantity of x minus 6 cannot equal 0, meaning neither x will be 0 nor x minus 6 will be 0. By adding 6 to both sides on that second one, x is not 0 and x is not 6. Putting that into set builder notation would just require putting the x bar, short for x is a real number such that, and then the curly Q braces around it. We switch those not equals to equals. That's telling us that we have two vertical asymptotes. Furthermore, I know that because what makes the denominator 0 versus what makes the numerator 0 is different. And so we would not have any common factors reducing. There won't be any holes in this graph. Let me copy this down. We had x minus 3 over x times the quantity x minus 6. If we had the denominator multiplied out, we'd have the degree of the numerator, which I'm going to abbreviate, less than the degree of the denominator. 1 is less than 2. So that's telling us that y equals 0 is the equation of the horizontal asymptote. Now we can furthermore find intercepts. What would make the numerator 0 does not make the denominator 0. So if we cross multiply it here, we can see why. Doesn't make the denominator 0. So we've got one x-intercept at 3, 0. And we can also find the y-intercept well, actually, no, we can't, because that involves putting in x equals 0, which would make the denominator 0. So considering the special values of x, we've come up with 0, 3, and 6. And give me a little more space here. We know the function is undefined when x is 0, UD short for undefined, and when x equals 6, and that y equals 0 when x is equal to 3. I want to know what's going on in between, what's going on to the left of the smallest value and to the right of the largest value. So left of 0, in between 0 and 3, in between 3 and 6, and then left of the largest value is 6. So R of negative 1. We're going to have negative 4 over negative 1 times negative 7. It's going to be negative 4/7. And then when we put in positive 1, we're going to have negative 2 over 1 times negative 5. And the negatives will cancel. We've got 2/5 or 0.4. When we put in 4 minus 3 over 4 times the quantity 4 minus 6. It's going to be 1 over 4 times negative 2, i.e. negative 1/8. And R of 7. 7 minus 3 over 7 times the quantity 7 minus 6. It's going to be 4 over 7 times 1. So positive 4/7. Now before we plot those points and graph, I want you to notice that at that first vertical asymptote, x equals 0, the sign is changing. That's because the multiplicity of the 0 of the denominator, x equals 0, that's 1, which is odd. So just like with x-intercepts, we would get a cross, which would mean a change in sign of the y's. We're going to see a change of sign of the y values to either side of the vertical asymptote x equals 0. Same thing for the x minus 6. That's only to the first power. That's odd. So we see a change in the signs to either side of x equals 6, going from negative to positive. And with the numerator, x minus 3, that's to the first power. So at the x-intercept, we'll have a cross. It's going from positive to negative. So when we plot those 5 points, as well as the 2 vertical asymptotes and the horizontal asymptote, notice, by the way, y equals 0 was the horizontal asymptote, and we have an x-intercept there. So we have an example where the horizontal asymptote can be crossed. When we fill in the rest, we're getting enough information that on the lower left, we're going to see a piece like this, the upper right, a piece like this, and then in between, a piece between the vertical asymptotes looking like this. Don't worry about the fact that the horizontal asymptote is being crossed at 3, 0. The end behavior we see on the far left and the far right, that this is flattening out. The y values are getting closer and closer to 0.